powder-based additive manufacturing methods can run into limitations with internal features, because loose powder must be removed from trapped geometries after 3D printing. Bound metal deposition technology, or BMD, circumvents these limitations by removing loose powder from the process. Pre-bound metal and polymer rods are extruded into complex shapes layer by layer. Because there is no bed of loose powder to be either bound or fused during the build, there is no loose powder to be removed from any internal or trapped features. The green part is sintered in the furnace after printing to remove the polymer and densify the metal. Our next generation separable supports also allow for easy post-processing with a ceramic release layer, which can be broken away by hand after sintering with no cutting tools required. Take this heat exchanger example that our application team developed. Compared to brazing, the traditional manufacturing process, the freedom of design of additive manufacturing offers the potential to increase heat exchange. The heat exchange design was 3D printed on the Studio system, and the extruded material leaves no loose powder behind. Because the Studio system has no expensive lasers or facility requirements, the cost of acquisition and operation of BMD is much lower than laser-based additive manufacturing, making part cost more competitive. The first prototype design has been printed and sintered, and our team is scaling full-sized heat exchange components in copper for leak and efficiency testing. They aim to highlight the advantages of bound metal deposition, with new design freedoms offering advanced performance and customization possibilities, and bound metal deposition offering efficient and cost-effective production. The value add of this new AM heat exchanger design, compared to off-the-shelf solutions out there today, feels limitless for engineers, customers, and designers alike. Learn more about the Studio system at teamdm.com/studio.